So our third lesson would be on cloud resource capacity planning. So in this lesson, this module will include an exercise on cloud capacity planning factors and cloud licensing, density, load, trends, and performance planning. And after completing this module, we should be able to define and describe capacity planning for resource requirements, investigate the AWS and Azure pricing calculators to assess budget concerns, define and describe user density and system load constraint, also with trend analysis including baseline patterns and anomalies, as well as performance capacity planning, and investigate the Azure platform to locate performance capacity requirement data. Alright, so in exercise 1, for cloud capacity planning factors, it's important to consider that there is always a cost associated with your resources, whether working on premises or in public cloud infrastructure. To measure the potential cost of cloud infrastructure, it is key for organizations to uh, plan what capacity they will require before building resources uh, to ensure that the costs are the most reasonable for the business and fall into agreed return on investments budget. Now, for cloud capacity planning factors on private cloud, when you begin to build a network in a cloud, you first need to ensure that you have everything you need to perform the kind of task relevant to your organization. When it comes to private infrastructure, it's important to not just consider what you may require for the immediate, but instead what you may also require in the future. Because of this, most private infrastructures will need to be developed based on what may be required for the future or risk users, putting strain on infrastructure or, in the instance that capacity is met, full denial of service. Because of this, the hardware for private infrastructures can be costly as the physical hardware needs to be stored and maintained by on premises staff, even if that hardware isn't currently being utilized to its full potential at that time of purchase. Now, purchasing hardware can be done in multiple ways. However, the cost of physical hardware can be spread over some time. But it's still key to remember that overall cost, not the immediate, is needed for the network to run in the long term. Now, on public cloud, on the other hand, it may be more beneficial for an organization to develop infrastructure on the cloud in terms of long term costs. Public cloud infrastructures follow a pay as you go model, meaning that the subscription costs payable to the cloud service provider are based solely on the resources spun up or the utilization of those resources, meaning that nothing goes to waste as could be the case with on premises. Although there are benefits to using public cloud infrastructure, there are also drawbacks compared to on premises, mainly in a more messy planning perspective. With public infrastructures, you are never sure of where your resources exist within the CSP data centers, and you are relying on them to avoid resource downtime and provide physical security for your resources, which is easier to manage when on premises. Now, for requirements, investigating what requirements your organization needs from a cloud infrastructure, you should consider the following questions, which is the business needs. What hardware or software does my organization need to meet the requirements of the infrastructure? On hardware, do we need any hardware that will require large investments? Is there any software that we need to purchase? How many users will require licenses for this software? On density, How many users are we expecting to utilize the infrastructure at any one time? And on budget, what's our budget for this infrastructure? Now, the answers and associated costs of the above questions will ultimately decide what sort of infrastructure is needed. There are also templates of existing infrastructures that can be used to gauge some of the answers to these questions. Now, these templates can be provided by multiple different tools online and allow you to produce ballpark figures depending on the above factors. It's likely that these templates will not be a one-to-one match of the infrastructure you need to create, as all organizations are different, but it's a good starting point, especially for budget analysis. Now, in licenses, when it comes to cloud infrastructures, there are different models of licensing options available for hardware, software, and overall infrastructure, such as per user. These licenses apply a cost per user, and depending on the infrastructure and software needed, typically have discounted the higher this number is. In volume based, this type of license depends on how many people or overall volume of people are utilizing an infrastructure. This is different from per user and instead refers more to a pay as you go billing methods than an upfront cost for license keys. In socket based, this type of licensing is based on the number of CPU sockets used on a motherboard and charged accordingly. Core based, like socket based licenses, these licenses charge you based on how many cores are utilized on a CPU or a vCPU. And in subscriptions, there are ongoing payments due for a specific subscription service and are typically at a set price over a certain period. An example of this may be a cloud access security broker that charges a set subscription amount to manage the security of your cloud infrastructure. Alright, so in this exercise, we will investigate the Azure and AWS pricing calculators to get an idea of budgetary constraints for cloud. Now, for our first task, it's to investigate Microsoft Azure pricing calculator. Now, creating resources using a cloud provider always involves a cost. Companies need to assess the cost involved when planning to migrate resources to a CSP, or cloud service provider. Now, upon creation of a resource, the subscription will be charged according to the consumption on a pay-as-you-go billing methodology. In this task, the Azure pricing calculator will be used to investigate the costing involved in the hosting of resources on the Azure platform. Now let's connect to our virtual machine. Now from this taskbar, let's click on the Microsoft Edge icon and click on the web address bar and type Azure pricing calculator. Now click on the pricing calculator. Azure web link, which is typically found as the first result. Now the pricing calculator page is displayed. Just click accept on the cookies. And if an online survey pop up, just click no. Scroll down the Azure pricing calculator webpage and select the virtual machines. When the virtual machine added pop-up window appears, click View. Alternatively, click to the bottom of the web page to get the virtual machine section. Let's click View. Now the prices shown on this website may differ from the screenshots. From the virtual machine section page, click on the region drop down and change the selection to UK South. Now the different regions in which resources can be created in Azure is displayed. The region can be changed according to your location. For the purpose of this exercise, the UK South region will be used. Now change the instance drop down. D8D. Version 4. Now, different virtual machine sizes have different costs. A company can use the pricing calculator to estimate the amount of a specific virtual machine will cost per month, depending on the resource utilization. Now, scroll to the bottom of the web page to the estimated upfront cost section. Click the currency drop down and change the selection to United Kingdom pounds. Currency. Now the Azure pricing calculator's currency can be changed to better understand the cost involved when creating resources on the Azure platform. For this task, it will be changed to the British pounds. Notice that the virtual machine upfront monthly costs have been calculated and shown in British pounds. Now on our second task, we will be investigating the Amazon Web Services pricing calculator. Now let's click on the new tab and check for AWS pricing calculator. Now on step 6, for the AWS pricing calculator webpage, click the Create Estimate button. Now, from the Select Service webpage, scroll down to Amazon EC2 and click Configure. Amazon EC2. And let's change the region to Europe, London. When the confirm region change pop-up window appears, just click change region. Now the same with the Azure, depending on the region you reside in, you can change this accordingly, but for the purpose of the lab, we'll be using the London region. Let's try it again. From the EC2 instance specifications, change the operating system drop-down setting to Windows Server. This one changed to Windows Server. So several different operating systems are available with different price ranges. A company can select the specific operating system and estimate the cost per month for the operating system. Under instance type, on step 11, change the memory value to 32. So instance type. Scroll down to the end of the AWS pricing calculator webpage to the Amazon easy to estimate section. Notice you can view the monthly cost and add to your estimates if required. Okay, now close all windows and proceed to the next exercise. Exercise number 2 is cloud density, load trends, and performance planning. Alongside capacity planning, it is also imperative to consider what performance is expected from a resource or infrastructure being developed on the cloud. It is easy in business environments to focus so much on capacity planning that resource planning takes a hit, or vice versa, but it's important to find a balance between the two. An infrastructure you have been instructed to build needs to have the resources available to meet the needs and objectives of the organization while at the same time staying within agreed baselines so as not to exceed budget and build resources that will be underutilized. Now, in cloud performance planning factors, number one would be performance requirements. The main considerations that will impact device performance, either on premises or in a public cloud, will be the following: CPU, which will be on how much power that does this device need to perform within agreed objectives. When it comes to memory, how fast does this device need to process things? How much memory is needed to perform even when scaled upwards in the future? When it comes to network interface cards, does this device require support to connect to or manage a wider network of devices? In storage, what level of storage is needed for this device? Are hard disk drives or solid state drives required? And in app responses time, how quickly does this application or infrastructure or service need to respond to users? These all need to be balanced when building VMs inside of public cloud or purchasing hardware or software for an on-premises cloud to meet the requirements while being scalable and within budget. Another one to note would be system load and user density. The above considerations will be mainly impacted by what sort of load you expect on a resource. Generally, the more load on systems, the slower they will perform until ultimately the device can no longer fulfill requests and therefore not functioning as expected by users. Therefore, it's important to consider how an infrastructure is working at current levels and that it is scalable to more users in the future as the organization and ultimately the demand on the infrastructure grows. If you notice that you are currently building and budgeting for a resource currently at capacity, it should be considered that this will not be sufficient to account for future growth. User density also impacts system load and refers to how many users could utilize a specific resource or overall infrastructure. This does not just apply to the maximum amount of users that could have an impact, but how many are expected to have an impact at the same time. For example, the picture that you manage for an infrastructure used by a certain department that works overseas that houses hundreds of individuals. Although during your work hours, utilization will be low due to differences in working hours, and the true impact will happen at once when those colleagues begin starting to utilize resources at once. So concurrency should be considered with users in mind. Trend analysis. Impact on infrastructure can be analyzed by looking at different trends, such as concurrency and system load. When analyzing your infrastructure, you should consider the following. For baselines, what is the basic level of performance required? And what is the average consumption of resources at any one time? Is the demand on the infrastructure as expected? When it comes to patterns, when are resources most utilized? Does this align with known parameters? And in anomalies, are there any anomalies in this data that can be accounted for when planning performance requirements? Are there huge upticks in demand at certain times? And these factors allow you to proactively plan what kind of performance power your infrastructure needs before it has been built, allowing much simpler management down the line. Okay, so for our first task, it will be to investigate resource planning in Microsoft Azure. Click on the Microsoft Edge icon pinned to the taskbar when opening. It will automatically reflect the Azure portal and sign in. Let's click on Create a Resource. From the categories menu on the left hand side of the page, select Compute. On the Compute section, scroll down to the list to Virtual Machine and click Create. Where is Virtual Machine? Wala siya. Compute section tayo. Wala yun. Back. Yan. Now this will open the Create a Virtual Machine portal and click the resource group. Select from the pre-populated resource group. When creating resource group in a real-world environment, you may have to create a new RG to bundle all extra resources as part of your infrastructure into one place. For example, when creating a virtual machine, you will also create a virtual network adapter, and a subnet, which all have their associated costs. And with multiple RGs, you can analyze cost based on each specific resource. Note that inside the lab environment, you will be unable to create a new RG. Now, step 7, click on the image drop-down menu and ensure that Ubuntu server is selected. Gen 2. Now, this is also an important factor of what will ultimately affect the cost of the infrastructure, as some operating systems can be more cost effective than others. But the operating system you choose should ultimately depend on the infrastructure you're looking to create. You should consider what role a device should have when choosing an operating system. For example, a low utilization device, an older version of Microsoft Server, or a Gen 1 image may be sufficient, provided it meets security requirements, or the most recent version may also be required if the opposite is true. Step 8, again, under the image section, click the Configure VM Generation link. Immediately when selecting the resource group, policy will apply to state the currency selected size is not compatible. That is because Ubuntu server does not support the SKU size and has been prohibited. Now on step 9, this will open the configure VM generation pane and select generation 1, click apply. In Azure Gen 1, images support most operating systems, and Gen 2 images support most 64-bit versions of Windows, Linux, and FreeBSD operating systems. Now that you have selected Gen 1, the error message that appears under size section will vanish. Step 10, scroll down to the size setting and click see all sizes. Now this will bring you to select a VM size portal and expand the A series version to drop down. When considering performance planning for resources in a public infrastructure, it's imperative that the correct sizes are used when creating new resources. Typically, in a real-world scenario, you will have specific requirements for what is needed for each resource, and you must ensure that this resource can meet these requirements. Click on the first entry. So these are built according to the number of cores used, and the prices of VMs also increase with the amount of RAM, storage disk, and other metrics that determine the raw power of the virtual machine. So it's key to only use resources that are required for your infrastructure, or you could risk going over budget. Now at the top of the page, click on Create a Virtual Machine breadcrumb web link to be taken back to the Create Virtual Machine portal. Okay. Scroll back up to the top of the page and click the Networking tab. This will bring you to the networking page, and as discussed above, you can see that the virtual machine portal will also create a relevant subnet and virtual network, both of which have their associated costs. Although comparatively a small cost, these should be considered when creating resources. And at the top of the page, click on the Management tab. From the Management page, you will see options of which services have been enabled on the VM before it's created. Here you could enable or disable a managed storage account or allocate a login to this device, linking it up with Azure Active Directory, again, which has its own cost. For step 18, click on the Microsoft Azure button to be brought back to the Azure dashboard. Alright, now if you ever receive any notification stating that your edits will be unsaved, just click OK. And we're back to the Azure dashboard. Let's close all windows and proceed to the review section. Right, now we've completed the cloud resource capacity planning, and it's done.